Welcome back. We are on lesson 3 with calculus by Larson. We're in the beginning of the book, Preparation for Calculus, P.3, Functions and Function Notation. All right, we're going to practice evaluating functions. To evaluate a function, all you do is you pick up the x value, 4 is x, and you plug it in for x. So g of 4 is equal to 4 squared, and then times 4 minus 4. Well, 4 minus 4 is 0, so right away it's 0. Okay, next up, put 3 over 2 in for x. So that gives us 3 over 2 squared times 3 over 2 minus 4. So 3 over 2 squared is 9/4. And 3 over 2 minus 4, that would be 8 over 2. So 3 minus 8 is negative 5 over 2, and then multiply straight across gives you negative 45 over 8. Next one, I'd like us to define g of c. So g of c means just put the c in for the x, so that would give you c squared times c minus 4. So instead of the letter x, it's the letter c. The next one takes a little bit of effort. They want us to find the g of t plus 4. So t plus 4 squared, because I'm putting t plus 4 in for this x and for this x. And then times, putting it in here now, t plus 4 minus 4. So foiling that out, you get t squared plus 8t plus 16. And that's gone, so just the letter t. Multiply across by t. So t to the third plus 8t squared plus 16t. And somebody at home is saying, what, how come t plus 4 is that? Because you have to FOIL it out. I'll do it up here. So t plus 4 squared means t plus 4 times t plus 4. So that gives you the t squared. The outer is 4t. The inner is 4t. And the last one's 16. So that's where the 8t comes from. Okay, the next one, number 12. This one's a little bit more effort. We got to do an f of x minus f of 1. All right, so f of x means put x in for x. It's this. This is f of x. So that's 3x minus 1. And then minus f of 1. So put a 1 in for x now. So 3 times 1 minus 1 all over x minus 1. So that gives us 3 minus 1 is 2. And it's 3x minus 1 minus 2. So it makes 3x minus 3 over x minus 1. You can factor out a 3 on the top. And so we can cancel those, and the answer is just 3. Okay, the next one down then. They'd like us to find the domain and the range of the function. So this is a square root function. It's negative and it's a plus. So that means that it shifted left 3. And the negative out here means that it reflected across the x-axis. And so when you graph it, so instead of it 0, 0, it went left 3. Then on top of that, it flipped across the x-axis, so it's going to look like this. And you can confirm that by double checking it on the calculator. So we've got negative, so y equals, so we got negative second square root of x plus 3, graph. So there it is. So I'd like to know the domain and the range of it. So remember, domain is how far it goes left and right, because the x-axis goes left and right. Domain means x. And so going left and right, starting from the left to the right, the smallest number to the left is the number negative 3. And then it's going forever in positive. So it's negative 3 to infinity. And then the range, again starting low, the range is the y's. So starting from how low it comes in at, and it's coming in at negative infinity. It's going forever down I know it's not going fast, but it is going down, and it's going to eventually get to that number. It's just not going quick. So it's coming in from negative infinity, and it stops right here at 0. At y equals 0, it doesn't go above that at all. So 0 with a bracket on it. Next one, we got an absolute value function. Remember, absolute value parent function is at 0, 0. It's minus 3. So that meant it had a horizontal shift to the right 3. And we can double check that again on a calculator. Absolute value is under the word math. There it is. Go over 1 the number. It's ABS. So ABS of x minus 3. And you'll get that V shape. So again, the domain is how far it goes left and right, and it's going infinitely left and right. It covers the whole x-axis left and right. It's going forever. And then the range, again, come up from how low it is. It starts here. So it starts at 0, and then it's going up forever. So 0 to infinity is the range on it. Okay, the next one. This one has a vertical asymptote at -4 because it's undefined at the number -4. And then on top of that, doing the horizontal asymptote, again, you're comparing the x's on the top and the bottom, the highest value of x on the top and bottom. So on the top we have an x, and on the bottom we have an x. So 1x and 1x, so the x's cancel out, and it's just 1. So y equal to 1 would be the horizontal asymptote. And then if you graphed it, you would see then that it goes in these two quadrants then. And again, you can verify that on the calculator. Remember to put parentheses around the top and parentheses around the bottom. So that gives us here then parentheses x minus 2 divided by parentheses x plus 4. And then graph it. Okay, so the domain, this function is not continuous. You have to pick your pencil up to draw the two pieces. So it's not a continuous function. It's got a gap. And when you go on left and right, the gap's at -4. So the domain going left and right is negative infinity to the number -4, and then union of -4 to infinity. Or you could say that the domain is all real numbers except for -4. And then the range, likewise, going up and down. We're going to miss this y equals 1 going up and down. So negative infinity to -1, union of -1 to infinity. Or you could say all real numbers except for -1. Okay, next we have a piecewise function. It says evaluate the function at the given values of the independent variable, then find the domain in the range. All right, let's go ahead and graph it. So we got a square root function. We want to start at the number 5 because it's for x less than or equal to 5. So at the number 5 is where we're starting. And at 5, when you plug a 5 in there for x, when you put 5 in, you get 9, and the square root of 9 is 3. Oh, let's go ahead and go for 0 and x. If you put 0 in, you get the square root of 4, which is 2. And it's going to keep on going all the way down to the number -4, because when it's -4, it becomes 0. And after that, it's undefined because you can't take the square root of a negative number. So it stops at -4. Then this function here starts at 5. So at 5, I know it's not technically starting at 5, but you need to start with that number because you're not going to start with 5.1 or 5.0001. It starts right after the number 5. So what we should do is put an open circle at where it starts at. So at the number 5, when you plug 5 in, it's 0. So 5, 0 is where it starts at. So I put an open circle on it. And then when everything greater than 5, so 6, would give you 1 squared or 1. And then I might as well jump forward a little bit. So 8 would be 3 squared 9. else did we had? We had 6, 1. All right. And it's going forever to infinity. This one stops there because it was for less than or equal to 5, so it's just a piece of that square root function. And likewise, this parabola, it's just the piece of it for when it's greater than 5. All right, so while we're there, we might as well do the domain and the range of it. So again, the domain goes left and right. So starting from as far left as it is, the smallest to the right, it starts there at that number -4. And then going to the right, it's going forever. Right here, there's a number. Right here. So there is an x value on the graph. And after that, there's an x value. So it's infinite. And then the range, again, starting low and going high, there's a dot there on 0. It counts. So 0, and then it's going up forever to infinity. There is a y value. So no matter where you look, there is a y value. I know there's a gap there. It's not continuous at that spot, but the fact is there are y values there. So there's no y values missing at all. They're all there from 0 up. All right, so then looking over here, when f is -3, that is going to be this one because that's less than 5. So that'd be the square root of -3 plus 4. So that gives you the square root of 1, r1. And then 0 is also less than 5, so the square root of 4, which is 2. And then 5 is the same one because it's equal to it. So that we saw that already. That gives you 9. Square root of 9, which is 3. And then 10 is this one because it's more than 5. So then that would be 10 minus 5 squared, or 5 squared, 25. All right, so down below is something I've been talking about. Horizontal shifts, left and right, are inside the function. If it's going to the left, it's plus c. If it's going to the right, it's minus the c. And then vertical shifts up and down are outside the f of x function. So minus c goes down, plus c goes up. Reflection on the x-axis if it's negative f of x. Reflection on the y-axis if it's f of negative x. And it's a reflection about the origin if they're both negative. That's something you're supposed to know. That would be flashcard time. Make some flashcards, or if you're Quizlet fans, make some Quizlets on it. So the next one on 48, I'm missing the directions on here, but what they want you to do is write down what the parent function is here in light gray. In light gray, that is the absolute value. And then what happened from there to the next one, it went up to. And so if it went up and down, that means it's outside of the x. So it was plus 2. The next one down, this light gray one, hopefully you realize that's y equals x cubed. And so it was at 0, 0. It moved, though, off of 0, 0. Went left 1, and then went up 2. So it went left 1, and it went up 2. So for the x, inside with the x, it'd be x plus 1 to the third, and up 2 plus 2. So it went left 1, so it's not minus 1. You got to do the opposite with the x. That made it plus 1, and then up 2, which is outside of it. All right. I think that might be it. Or is there one more page? There is. There's more. Just wait. There's more. All right. This one, I like this one. This is my favorite of all. This is the one that would kill their grades in a college class I was taking. It's a department final. And this is like one question in the homework, and then they made it this monster question on the final, which was just exhausting to me because they really had no practice at it. But anyway, I'll focus. So given points here, -4, -3, and 2, 1, they'd like you to do these different shifts on it. So for example, the first one here, -4, is going to be taking all the points right 4, or you could say x plus 4. The y didn't change at all. And the next one you can't really see, but it's plus 2. That means that it's left 2. So that would make it x minus 2 comma y. The next one has a plus 4. It's outside of it. So that's the y, and so that'd be up 4. So we've got x comma y plus 4. And here we got minus 1, so we're down 1. So the x stays the same, and then y is minus 1. 2f of x, so that's 2 on the y because it's outside f of x. So it's going to be a vertical stretch times 2. So the x stays the same, but the y is times 2. This is going to be a vertical shrink when you're multiplying by a number less than 1. So vertical shrink times a half. And so the y would be times a half. Negative x, so that's inside with the x, so that makes a reflection across the y-axis. Something you got to remember. Make some flashcards. So the x stays, so the x changes and the y stays the same, so you're going to make negative x's. All right, this is negative for the y, so the y is going to be negative this time. And so since the y is negative, that makes it a reflection over the x-axis. So let me do like 2 of these. So, we'll do this shrink for fun. Let me do it with a different color, and I'm going to graph it on the same graph. Let's see here. I'll use red. All right, so what I meant is the x stays the same, so that stays 2, but the y is times a half, so that makes 2 comma 1 half. The x stays the same, negative 4, but the y was negative 3 times a half would make negative 1.5. So 2 1 half, and then we got negative 4, negative 1 1/2. Then one more. We'll go ahead and do maybe this one. So again, the x stays the same, but the y changes signs. So it becomes 2 negative 1 and negative 4 positive 3. So 2 negative 1 and negative 4 positive 3. All right, so, all right. See you in class tomorrow.